Hello all. So in this video, we're still going to continue our discussion of pseudocode, but here what we'll do is go through a few examples of how to create pseudocode from scratch. So I haven't prepared the pseudocode in advance for these videos or for these examples, but I will do it on the fly so you can see the process. And you can see that it's not necessarily a linear process, that sometimes it's a problem solving problem. So sometimes one part of the problem makes more sense, and once you do that, then you can make a little more sense of the next step and so forth. So enjoy. All right, so I want to give some examples. And so what I'm going to do is to flip between this view, and I just opened a text document where I'm actually going to write the pseudocode. So I'm going to go through my preliminary thinking first, and then we'll go over and look and do the pseudocode in a separate file. So here's my first problem. Suppose I have a list of names. So this is assuming we're going to do this in a language like Python. It'll be a list or array of strings, but we don't really even have to think about it in those terms unless it becomes really important. I have a list of names, and I want to make a new list that has all of the names that start with a certain letter. So one of the things I immediately think of is, oh, well, I could make that letter be variable, be an input, and then I could solve a lot of different problems with the same algorithm that I write. So there's data that I want the algorithm to operate on. That includes the letter, which could be specified as an input, and the list of names. I don't want this to work only for one list of names. I want it to work for any list of names. We like processes that are general and work on a lot of different inputs. I'd like to have a process that works on any letter that I want to look at. So I'm going to make those inputs to the algorithm, and I'd write the starting line of the pseudocode like this. Algorithm select names, takes in a letter and a name list. All right, now I'm going to switch over to, in this case, this is PyCharm, but if you notice, I am in a file, a file that is not a .py file. It's not a coding file. This is just a text file. So I want to write pseudocode. I don't need it to be compilable, so I'll just put it here. All right, so I want to copy over what I had. Algorithm select names letter name list. Now, one of the things that is good to do when you're getting ready to write out pseudocode or getting ready to solve a problem is to think through a short example in your head. So I'm going to imagine that letter is S, and my name list, I need a short but helpful name list. All right, so we'll just keep it simple. Oops, I lost my quote mark. So if I have the letter S and I have this name list, what I want is, first of all, what's the correct answer? I want to select out the names and put them in a new list, that all of the names that start with the letter S. So what I would like to get out of this is something that looks like this, or I suppose I could be happy with having it in some other order. Either of those would be fine. So how will I go about finding those? And here's where this is the actual problem solving. Like, I have to be aware of exactly how the computer would do this sort of thing and what the tools are, but I don't have to worry about like this particular specific notation. I somehow have to have it look at every name in here, and so that I can tell which ones I want to keep in my answer list and which ones I don't want to keep in my answer list. And that means I need to have a loop that goes over this list. This one example happens to be 4 long. I could give it a list 40 long. I want it to work on that as well. So a loop is definitely going to be called for. So I know somewhere up here I'm going to need a loop over names in name list. All right, so far so good on that front. So that's going to be one of my steps. I don't know what step exactly at this point, so I'm not going to try to get any more specific. Now, sometimes when we do this, we want to set up a loop variable, so we'll kind of phrase this differently. We'll say like repeat for name in name list. That's another way to do this. Again, this is getting closer to code. It's a little more cryptic. You could also do this in English. Each time, let name be the next name each time. So I can just write it out in English. Let name be the next name each time. That gives me a loop variable that's going to have Seth the first time for my example, and then Charlie, and then Samantha, and then Nikki. All right, what do I want to do with those once I have them? Well, inside the loop, as I go through it, I want to check what the first letter of each name is. So that's the next thing I'm going to do. And because I want it inside the loop, I'm going to indent it. And I'll say, I know that I want to do something with this, so I'm going to say if the first letter in name equals letter, then do something. And we know from our experience with this that we might want to have an otherwise case. So if you don't like using else here, which is a little cryptic, you could say otherwise, do something else. And somehow in the process now, we have to figure out what we want to do here. So we want to have an answer list, and if the first name equals the letter, then we want to add that name to that answer list. I'm just going to assume I have a variable called answer list. And we might not have anything to do here. If you end up being like, oh, well, if otherwise don't do anything, then all of this can go away. I don't actually need to write this at all. If it doesn't do anything, it doesn't need to be there. At the very end of things, I want to return or output the answer list. So whatever I'm supposed to do with this, I want to do that after the loop ends, once I have collected up all the names. Now the only other thing that I would add in here besides maybe step numbers, which I'll do in a second, would be to say set up answer list as an empty list. There. And once I'm done with that, I can get rid of my scratchings about the example. That's all good. This is an algorithm in pseudocode for this problem. All right, let's go back and look at one more example, and then we'll be done with this video. The second example is a little more complicated. So I'm going to talk through what we want to do carefully first, and we'll talk about data types and data representations, and then we'll come back and see if we can turn this into actual pseudocode. I could very easily, this is more complicated and I haven't written it out before, so I could easily mess this one up. All right, so suppose that I'm taking a road trip and I want to calculate not just the hours I spend traveling, but specifically how many hours I spend driving versus not counting time that I spend stopped at a gas station or stopped at a rest stop or stopped because I'm eating or any other reason why I might possibly stop the car and not be driving. I want to not count that time, and I just want to get a sense of exactly what the driving time was. So I'm going to do this by writing down on my trip all of the times when I either started driving or stopped driving in a given day. There are some simplifying assumptions we're going to make here. So for simplicity, I'm going to write down the times in 24-hour time. So that means we don't have AM and PM. When we pass 12 noon, we go to 13, 14, 15. And the last hour of the day is 23 o'clock. So 11 p.m. is 23 p.m., 23 o'clock. And then we're also going to make the simplifying assumption that we won't ever drive past 11 p.m. just so we don't have to worry about one day's drive spilling over into the next day. And especially we don't have to worry about the 23:59 turning over into 0 hour. Because that's how 24-hour time works too at the beginning. 12 midnight is 0 o'clock, and so forth. All right. So we're not going to have to worry about things happening in the middle of the night. We're just going to worry about driving within the confines of one day. So here's a record of one day's drive. I started driving at 8 in the morning. I stopped for gas. I started driving again, stopped for lunch. I stopped to see some roadside attraction in the afternoon, and I finally stopped for the evening at 10:35 p.m. Oops, sorry. I have to pull that up where you can see it all. So here, you can see the day's drive with the times listed in the 24-hour time. I want to write an algorithm that can take in this kind of data, not this specific data, but this kind of data, and it can calculate how many hours you actually spent driving. So one of the things to note here is, assuming we start driving at the beginning of the day and we've stopped driving at the end, we have pairs. All of these times pair up. There's a start driving and a stop driving and a start driving and a stop driving and so forth. So we'll always have an even number of these no matter what we do. And it'll always start with a starting time and then the next number is a stopping time and so forth. So the time we spent driving is the time that elapsed between the first time and the second time, plus the time elapsed between the third and the fourth, plus the time elapsed between the fifth and the sixth, and plus the time elapsed between the seventh and the eighth. So if we pair those up and calculate the time elapsed and add them all up, that will give us the total time that we spent driving. Make sure that makes sense to you. All right. Before we actually get to the algorithm in pseudocode, we have to figure out what the data is going to look like, because that's always important. So we're going to represent the data in Python in some way. Usually in this beginning class or similar classes will give you the data representation. We'll say, here you have a list. It looks like this. It holds this data. But if you're writing your own code, you have to figure this out on your own. So each time of day has an hour of the day and a number of minutes. These, we can't just add them together, right? We could represent, either calculate the hour of the day in minutes and then add the minutes to it so that all our times are just in minutes. We could represent the number of minutes as a fraction of an hour and end up with floating point numbers. But I'll tell you right now, as a programmer, I tend to avoid floating point numbers if I can possibly help it, because they are less accurate for this kind of a problem than just storing things as minutes or keeping the hours and minutes separate. So just as thinking of an input to this program, we're going to keep things simple. We're going to represent a time like 10:45 as a list containing the 10, which is the hours, and the 45, which is the minutes. So then I can represent this whole list, this record that I had from one day's journey, as a list, which I've written out right here. 8:10, 10:45, 11:05, 13:10. That's not right. What did I? That should be 14 o'clock. That's a typo. That should be 14. This should be 14 o'clock, and then so forth for all the other times. So that's the information we're going to assume we have when we actually start writing the algorithm. Okay, I'm going to switch over to my other view. And I'm going to move myself off to the corner a little bit. I wasn't quite in the corner last time. All right, so what do we want to do? We want algorithm, compute, drive, time. It's going to take in start, stop, list. That's its input. Ooh, okay, we got to figure out how to do this. I said before, they come in pairs, right? So we want to work with them in pairs. So fundamentally in this algorithm, we're going to be going through this list, the start stop list, but we want to go through it looking at at the first and the second, the third and the fourth, and so forth. So we need to find a way just to describe that in English. Repeat over pairs from start stop list. Well, this is going to get too long. Now, we've done enough Python programming. You might be starting to think, oh, there's a way to do this. There's a way to do this in Python, but we're not going to describe it right here in Python. So I just want to repeat over the pairs from the start stop list. I give a little example of what that looks like. That's good enough. Now, the reason I stopped what I was doing before is I'm just going to have steps where I say let start be the first time of the current pair. Let stop be the second time of the current pair, right? So we're looping over these pairs. I'm going to grab the first one as the start time, the second one as the end time. Convert start to be just minutes. Convert stop to be in minutes. Now this is, I could actually give the formula here, right? How do you convert if I have well, it gets a little complicated. I've got a list with two values in it. I want to take the first value, which is the number, and I want to multiply it by 60 to convert it to minutes and add it to the second value from the list. So this would be, I can write this out in kind of codey terms. Start sub 0 times 60 plus start sub 1. And I can do the same thing down here. Can I type today? No, I cannot. Okay. Now we've got our 2 times in minutes, all in minutes. And we're going to compute elapsed minutes as stop minus start. Right? We just have the difference between them. Convert that to hours. Now here, if I said we want to get the hours back, then we could leave our total in minutes and convert it to hours at the end. That's probably more accurate. So maybe I'll do that. I'm not going to convert them to minutes here. I'll convert the result to minutes before I'm done. All right, the only other thing left is, well, I need to add these together. And anytime you have elements, calculations you're doing where they're part of a loop and you're adding them together, the accumulator pattern applies to algorithms and pseudocode just as it does to when you write actual code. So I need to set up a total time, total mins, that's going to start off at 0. And then I want to add the new value that I've just computed to the total minutes. That's all I want to do in the loop. Just figure out the difference between the two in minutes, add it to this accumulator variable that's adding up all of the ones that I find over the course of the loop. And the last step is I want to convert that to hours and return it. So I take total minutes and I divide it by 60. If I wanted to convert it to hours and minutes precisely, that would take a little more work, but I'm just going to leave it there. this is perfectly good pseudocode. This is the kind of thing that we're looking for and the level of detail that we want. So each of these I can probably do with a single line, maybe 2 or 3 if in the worst case, and it has some structure that's familiar, but otherwise it's written in English. And that lets us get around remembering exactly how do I do this? Exactly how do I repeat over the pairs? That is something we can figure out when we translate it into code. All right, so this has been intended to review some ideas that we talked about earlier in the semester, and then to add to that by giving you more examples of algorithms in pseudocode. Hopefully this will demystify it a little bit for you. I don't want people to stress out over how to write pseudocode. It's meant to be easier than it is to write actual code on the fly. And it's meant to be a great tool to use when you're trying to organize your thinking so that when you come to actually writing code, you know exactly what it is you want to do. I'm going to stop there, and I'll see you all very soon.